Hello, this is Maria from mathmammoth.com, and in this lesson we're going to look at equations for linear functions. My first example shows a linear function here and its graph. We have the time axis. As time goes on, then there's a cost in dollars. You can think of, for example, renting some equipment or maybe hiring someone to work for you, but there's an initial fee. What I mean by that is that at 0 hours, the cost is $30. So maybe if you're hiring somebody, they come to your house, you have to pay them $30 just to come to your house. Then after that, you pay them according to time. Now, this double line here at the axis means that this vertical axis, the scaling here does not start from 0. In other words, some of the axis is not shown. It's like cut off. In fact, if you look at these numbers, there's 90, 70, 50, 30. So here would actually be 10 right there. The initial value of any function is its value when the input is 0. Time is our input, cost is our output. So the initial value of this function is $30. And in general, the initial value of a function is its value when the input is 0. Now, what is the rate of change of this function? We could look at the table of values, and for example, when the time increases from 1 to 2, and it was 1 hour increase, the cost increases by 20, from 50 to 70. The same here, from 2 hours to 3 hours, the cost increases by 20. Or if you go from 2.5 to 3.5, the same thing. So the rate of change is $20 per hour. But there's an initial fee, the $30, just to get started, so to speak. So let's write the rate of change here. It was 20 per hour. And with those, we can now write an equation for the function, or for the output. Basically, the equation for the cost based on time. Each hour costs you $20, and then initially you have to pay the 30. So the cost, if cost is C, based on time, if time is T, for each hour of time you pay 20. 20 times the hours, plus the initial value 30. Now, let me copy that equation here. The same situation, we had cost equals 20t plus 30. I can ask two kinds of questions about this situation. Questions about the cost, and then questions about the time. So here I have two example questions that typically can be asked when you have the equation. How much does it cost to rent this equipment or hire this person for 11 hours? That's asking for the cost. How much does it cost? And the time is known, 11 hours. And then the other way around, for how many hours can I rent this equipment with $245? So here you know the cost and you're asked the time. To solve both, I can use the equation now. The equation of this linear function, since I have it. So C equals 20t plus 30. Cost based on time, and the time is 11 hours, so I just plug it in. 20 times 11 hours plus 30. So this is 220 plus 30, $250. For how many hours can I rent this equipment with 245? Here, the T is not known, but C is known, so I will write 245 in place of C. And then solve for this, subtract 30 from both sides, and now divide by 20. 200 divided by 20 is 10, and then 15 divided by 20 is 3/4. So it's going to be 10 and 3/4. All right, let's go on. Here's some general information. Every time we have a linear function, its equation is of this same exact form. The equation y equals mx plus b defines a linear function, where x is the independent variable, or the input, y is the dependent variable, or the output, b is the initial value, and then m is the rate of change. So, one more time. For each linear function, there is this type of equation. And if the equation for a function is of this type, then it is a linear function. One more time, I wrote here the equation for a generic linear function. And we've seen how you can also give a linear function as a table of values or as a graph. Each linear function would also have a graph. You need to be able to switch between these three representations: the graph, the table of values, and the equation. For example, from the table of values or from the graph, you should be able to write the equation. And you do that by getting the rate of change, the m, and the b. Or, if you're given the equation, you should be able to make the graph and make a table of values, and so on. So let's practice that a little. All right, here is a linear function, and I want you to write an equation for it from the graph. The equation will be of the form y equals mx plus b. M is the rate of change, b is the initial value. You can read both of those from the graph. The initial value is the easiest. It's the value when the independent variable is 0, or the input variable. So we read it, it's 600. And then the rate of change. Notice this line is going downhill, so the rate of change will be negative. You choose 2 points from here, any 2 points, and it will be easiest if you can find points where the line here is crossing grid lines. Okay, maybe this last one, which is 75. The time is 75 minutes, and then the first one when the time was 0. Those two. So how much does the volume, the output variable, change? From 600 to 200, okay? So it changed by negative 400, and the time is 75. Okay, and this simplifies. Both of these are divisible by 25. How many times does 25 go to 400? Well, it goes 4 times to 100, and so therefore 4 times as many times to 400, or 16 times. Minus 16 over 3. And so we get the equation. Well, y equals mx plus b. Actually, here my variables are t and v. V is the output. I put my rate of change here, times t plus the 600. So this will give me gallons if I put in here minutes. A question: when will the volume of water be 50 gallons? If this is volume of water, yeah, this volume is going down. Maybe it is the volume of a tank of water and the water is being released from it or used up. It's asking for time and the volume is given. So we know that the volume is 50. I'll put it here in place of v. This is the equation to solve, to know when the volume of water will be 50. We solve for t. Okay, there's a fraction here, so let's start by multiplying by 3. Now when I multiply by 3, I need to multiply both terms, this and this, by 3. And then subtract this. Lastly, divide by negative 16. We'll get the positive answer now, negative divided by negative. And from a calculator, it is about 103.1 minutes. Does that make sense based on the graph? Let's go look. About 103 minutes. It's off my graph here, but if I continue this to 103 minutes over here, the volume of water would be over there, yeah, 50 gallons. Yes, it makes sense. All right, our last example for this lesson. Again, here is a linear function, and we have a table of values for it. Write an equation for it. Okay, input values are here, the input variable, time, and this is distance in kilometers. So when time starts running, the distance is 51 kilometers. Maybe it is a car or some vehicle that's already at a 51 kilometer mark somewhere, and then it continues driving from that point onward. Our initial value is 51. The generic form was once again y equals mx plus b. This time our variables are t and d, so it will be d equals m times t plus b. B is the initial value, it's 51. But what is the rate of change? the rate of change, okay, we will look at how much the output variable changes compared to the input variable. So we get this difference, 235 minus 51 over 8 minus 0, or 8. This is 184 divided by 8, which is exactly 23. So now I have my equation. D equals 23t plus 51. And then a question, what will be the distance when the time is 7.5 hours? The time is this. T is given, so I will plug this number in place of t, and I will get my d, or distance. And from a calculator we get 223.5 kilometers. Alright, this is all for now, and I hope it was helpful.